This is a video on simplifying complex rational expressions, also known as simplifying complex fractions. We're going to start with the fraction 1, I need a writing utensil, 1/2 plus 3 over x, all divided by x plus 3 over 4. Now we know that x in this situation cannot equal -3 or 0. -3 in the denominator would make a 0 in the denominator. 0 up here in this denominator would make an undefined fraction as well. Okay, the first step is to look at your whole numerator. Your whole numerator has two different fractions, 1/2 and 3 over x. We need to find a common denominator for those two fractions. Our common denominator is going to be 2x. So I need to change 1/2 into a fraction over 2x. Okay, so I'm going to draw my fraction bar here. Put my equal sign. All right, so if I want this to be a 2x on the bottom, that means I have to multiply top and bottom by x. So I'm going to have x over 2x. If I were to reduce that down, I'd still see the 1/2. Okay, plus this has to be a 2x as well, so I'm going to have to multiply top and bottom by 2, so 6 over 2x. And that's still 3 over x. Okay, my denominator can stay as x plus 3 over 4 because it already has a common denominator. Okay, now I'm going to rewrite the numerator as having one denominator. It's going to be 2x, and it's going to be x plus 6 over 2x, all over x plus 3 over 4. Now when you divide fractions, remember it's the same as multiplying by the reciprocal, so I'm going to keep my x plus 6 over 2x, but I'm going to multiply by the reciprocal of x plus 3 over 4, so times 4 over x plus 3. Okay, and so now I'm just going to multiply 4 times x plus 6 all over 2x times x plus 3. Now I'm not going to multiply it through yet because I want to see if I can cancel some factors before I multiply. It looks like I can cancel a 2 in the denominator with a 4 in the numerator, and so I'm going to have, canceling that, 2 times x plus 6 all over x times x plus 3. And that is simplifying my rational expression. Okay, let's do another one. Let's go with x squared. That's an x squared. Let's try that again here. Okay. X squared over x minus 4 plus 2 all over 2x minus 2 all over x minus 1. And our job is to simplify this complex or rational expression. Okay, so first of all, we have to get common denominators in our numerator. It looks like my common denominator, if I put this over 1, is going to be just 1 times x minus 4 or x minus 4. So in my numerator, my denominator is x minus 4. I keep the first term, but the numerator in this side has to be multiplied by x minus 4. And that's all over. We're going to do the same in our denominator. Let's see here. Looks like our common denominator is x. I'll keep the first term, 2x minus 2, but over here I'm going to have an x, because 1 is x over x. Okay, now I'm going to rewrite these so they all have a single denominator in the numerator and denominator. So x minus 4, x squared plus 2 times x minus 4. And my denominator is 2 times x, or 2x minus 2, minus x, all over x. Now we have to do some simplifying. Okay, so it looks like we have x squared plus 2x minus 8 all over x minus 4. And that's still all over 2x minus x, which is x, minus 2 all over x. I'm going to multiply by the reciprocal. So x squared plus 2x minus 8 all over x minus 4 times x over x minus 2. Okay, extend my page a bit here. Now I need to see if I can factor this top term over here, this numerator in the first term. So x squared plus 2x minus 8. I bet that factors. So let's see here. I'm going to go two binomials, x and x. Factors of 8 that subtract 2 would be 4 and 2. I need a positive on the 2x, so it looks like that, and that's still over x minus 4. And this is still times x over x minus 2. I'm going to put this in parentheses just so I can see. I can see it looks like I'm going to cancel some factors. This x minus 2 is going to cancel out there. Okay, so I'm left with x plus 4 times x all over x minus 4. So I'm going to put x in the front, x plus 4 all over x minus 4. And there's my final answer. Okay, now if I look back to see if I had any restraints on this thing or any domain issues, I'm going to go back up here to the top. Whoops, I had a little problem scrolling back up here. In this numerator, or in this problem up here at the top, I have a no 4, so x cannot equal 4. X cannot equal 0. So if there's anything else x can't be, and it can't be a 2, I believe. Let's see here. 0, 4, and 2. If I plug in a 2, 2 times 2 is 4, minus 2 over 2, and that's going to give me a 0 there. No, sorry. 2 times 2 is 4, minus 2 is 2. 2 over 2 is 1, 1 minus 1, so that's a 2. Can't have a 2. All right, and so now I have my restrictions on. And so I have my final answer right here. Okay. Let's do one more. Okay, let's start with 3 over x plus 1 all over x over 2 minus 3. Okay, restrictions here. It looks like x can't be 0. Let's see here. And it can't be 6. 6 over 2 is 3, so it can't be 6. Okay. Now let's go ahead and simplify our expression, our complex fraction. Common denominators in the top will be x. Okay, so I'm going to keep my 3 over x, but I'm going to plus x over x all over. Common denominators in the denominator would be 2. I'm going to keep my x over 2 minus, let's add 6 over 2, because 6 over 2 is 3. Okay, I'm going to rewrite this. So they have single denominator. 3 plus x over x all over x minus 6 over 2. Then I'm going to multiply by the reciprocal. 3 plus x over x times 2 over x minus 6. And it looks like I have 2 times 3 plus x all over x times x minus 6. And I have no factors that I can reduce, so this is my final answer. Okay, that was a short video on simplifying complex rational expressions, or also known as complex fractions.